Okay, Aubrey, we are writing proofs. This is the homework for this. I gotta kind of go fast because I'm getting ready to leave to take a kid to the dentist. So we are getting ready to write proofs. Here is what a proof is. You are trying to show why something is or is not the way that it is and give justification. You do this all the time. You do not do it for math all the time, but if you are at home and you are like, Mom, I should be able to go out this weekend because I did this and this and this. The whole because I did this and this and this is justifying your reasoning. That is writing a proof, basically. You are showing a valid argument by providing evidence, okay? You do this all the time. I am making you a good arguer by talking about this stuff, okay? Now, we are going to put it into terms of like math-related things, which may be a little bit more boring to you. But what we're trying to do is justify our answers. We're trying to provide evidence. We're trying to see if things are true or not true. Okay, here we go. We might not get done with this today. We'll see. Okay? When we write a proof, we have to have some factual information. Like deductive reasoning is based upon facts. Okay, Wyatt, stop. Okay, if you guys do that anymore, I'm going to make you lick that off the table. No more. I don't care. I had to wipe it off the table this morning. I'm not doing it again. Knock it off. Get rid of it. Okay, we have to start with some, shush. We have to start with some factual information. Here are the facts that we know. Ready? I'll go through these real quick and we'll see if they make sense. 3:1 says through any 2 points I can create a line. If I have 2 points, I can draw a line between them. That sounds like a no-brainer, right? This is a factual piece of information, okay? These are called postulates, and postulates are little baby facts. Okay, 3:2 says through any 3 points, there is a plane. 3 points, can't create a line unless they're all 3 together, but through any 3 non-collinear points, it says, they're not in a straight line, they're creating a flat surface. That's a plane, okay? Number 3, a line contains at least 2 points. That is a little bit different than 3:1. 3:1 says 2 points to make a line, but the other one says a line contains at least 2 points, which means it could contain more, right? So write this down. Maybe more than 2. That's what 3:3 is saying. It might contain more than 2 points, okay? 3:2 said there have to be 3 points to create a plane, but 3:4 says there might be more than 3. Maybe more than 3 points on that plane. Okay, there have to be at least 3, but there might be more than 3, is what 3:4 is saying. 3:5, if 2 points lie in a plane, then the line containing those points lies in a plane. So here's my flat surface, ready? And I have a dot here and a dot here, and if I draw a line between them, that line lies on that flat surface. Does that sound silly? A little bit. Because, like, why do we have to say that, right? Okay. If 2 lines intersect, what do they make? Like, where do they touch each other? They create 1 point where they touch each other, right? If 2 lines intersect, okay? So, exactly 1 point. If 2 planes intersect, 2 flat surfaces intersect, what happens to them? They make a line, right? Like the floor and the wall creates a line where they touch each other, right? It's not just 1 point where they're touching. It's a whole line where they're touching. Okay, that's 3:7. All right, here we go. Example 1. We are just trying to use these facts to support why something is or is not. Okay, we're not writing a full-blown proof yet. Example 1. Explain how the photo down below illustrates each one of these things. Okay, so it says line N and P intersect at point D. Line N, which is this guy here, and line P intersect at point D. Okay, which piece of information up here tells me that line N and P should intersect at a point? 3:6. If 2 lines intersect, then they intersect at exactly 1 point. Yes. Postulate 3.6 is the piece of factual information that tells me that this should be true. 2 lines should make a point, and that is postulate 3.6. Okay, we're just saying, here's why this backs up as true. Got it? B says points A, B, and D determine a plane. Those are 3 points that are creating a plane. A, B, and D are these 3 points. This one, this one, this one. They're making this flat surface, yeah? Okay, making that flat surface. All right, which one of these says that if I have 3 points, they make a plane? 3:2, through any 3 non-collinear points is exactly 1 plane. Sounds good to me. Postulate 3.2. There you go. Okay? C says the plane that contains A, D, and E intersect the plane that contains F, G, and E to make line K. So I have two planes that are intersecting to make this line K right here. Those are the two sides of the skyscraper, right? Which one of these theorems says that those two planes should intersect to make a line?
Do we need to memorize the postulate?
No, you do not. 3.7, right? Postulate 3.7. I'm just showing you why this backs up as true. Postulate 3.7. Any two planes intersect to make a line. Got it? Okay. All right, using postulates. Now, this is a little bit harder. This is a little trickier. We're going to look at each one of these statements and say, okay, is that always true? Is that sometimes true, or is that never true? Always, sometimes, never. All right, so let's talk about this one. The intersection of three planes. So we're talking about three pieces of paper that are intersecting, and they form a line. Okay. Can three pieces of paper intersect in one line? Here's what I'm thinking. I'm going to use Wyatt's book. This piece of paper, this piece of paper, this piece of paper. They're intersecting and they're forming a line in the binding, right? Yeah. True?
Okay.
Okay, do they always form a line when three planes intersect? Okay? Think of the floor, this wall, and now let's do the ceiling. The ceiling, this wall, and that wall. Where do they touch? All three touch at one spot. Just that one corner is where all three of them touch, right? So, three planes could intersect in a point, or like the binding on a book, it can intersect to make one single line, right? So always, sometimes, never true.
Sometimes.
Sometimes. Do you see how this works? Okay, here's what I want you to do. B. Always, sometimes, never. And C. Always, sometimes, never. You come up with an answer. Put it on your piece of paper. Tomorrow? We are 2nd and 7th and 4 times. Yeah, 6 and 4. Okay, all right. Okay.
We're just gonna do lessons and
Stats will be doing a review, and we might be testing on Thursday actually in stats. We're taking a test over to the Shepherd. So there's that, and then yeah, we'll just do the next section. So we'll start 1-4 tomorrow. Okay. All right, here we go. B. Okay.
Yeah, I got it.
All right, B. Line R contains only point P. Never. We have to have 2 lines or 2 points to make a line. So never true.
Sometimes.
What?
Sometimes, because it can
It has
only
to
contain.
It has to contain. It says postulate 3.3 states that a line contains at least 2 points. You have to have 2 points to make a line.
Ours does.
To have a start and an end. Okay?
Doesn't count as a
No. Line R is just the name of him. Good question. Okay. Through points H and K, there is exactly one line. H and K are 2 points. Can I draw, if this is H and this is K, can I draw 2 lines through them? I could, but they're the same line, right? I could draw as many lines as I want to, but it's going to be exactly the same, right? H and K are exactly the same line, one line through them, so always, right? Yep. Yeah? You got to think a little bit about how this works, okay? Good? All right. 2-column proof. I don't know if I want to start a 2-column proof yet.
Well, we have to do that before.
Yeah, let's do this. Let's do this. Here's what I want you to do. I'm going to change the homework assignment a little bit. We're going to separate this into 2 days. I'm not going to start proofs yet today. We're going to finish that and do that tomorrow. But I'm going to change this. And I want you to do 1 through 10 all. 1 through 10 all. Okay, so change that. 1 through 10 all. 5 through 10, you're just doing always, sometimes, never. That's not that bad. Okay?
Do we have to explain the postulate?
1 through 10 all. You need to list the postulate. You do not have to write the postulate down. Just write POST 3.1 or POST 3.7 or whichever postulate identifies that. Okay?
So like 1, for example, would be postulate 3.2.
I have no idea.
That's all we did.
Yeah, but it's not 3.2. But yes, you're right. Yes, that's all you have to put. Okay? And then always, sometimes, never. What? Because it's chapter 3. We'll do postulates in chapter 4 where they're all 4 point whatever. Okay. Yep. It's just a way of naming them. Yep. If they just called it 1, 2, 3, 4, then chapter 4 we would have 1, 2, 3, 4 and it'd be confusing. So, okay. What? Whichever one supports
So what
this
would
right here.
number 1 be?
So like number 1, planes O and M intersect to form a line. We're talking about 2 planes intersecting to form a line. Which one is that? 2 planes intersect to make a line. Which one is that?
7.
I think that probably sounds right. 3, 7. If 2 planes intersect, they form a line. Yes, postulate 3, 7. That's all you have to put. Which piece of information tells you that that has to be true, right? Okay. Okay. All right. Goodbye, Aubrey.